All right, so if you have a look at your learning guide, what you will see is obviously the breakdown of the different terms. So obviously we're at the end of this term. We were going to do the start of the design patterns with something called the visitor design pattern. We've decided to move the design pattern talk to where it's appropriate, which is going to be after your practical test. Speaking of your practical test, as mentioned previously, it will be across 2 days because we don't have enough venues because of COVID policy, and you will have to book for one of those days. So that booking information will be made available tomorrow, probably afternoon, and you'll have to book on E for that. Once a certain day is full, that's full. There's no other space available. If you have a specific reason why you can't write on one day or the other, you should all be able to write on the Tuesday because that's the original time. The other date is a Saturday. There are some religious reasons why you cannot write on a Saturday. Then obviously we will make a plan for you. Other things to note in the learning guide is this practical X. You'll see the design there is given out during recess. It's only due in week 10, but at the end of week 12 or beginning of week 12, you see that the actual final practical is due. And if you look a bit later, you will see there's a short discussion on practical X in the learning guide as well. So that's what we're going to have a look at. We're going to have a look at what practical X is. It's meant to test your ability to understand all the concepts taught in Computer Science 2A, and then obviously apply that to a certain situation. So what concepts are we going to have a look at? Well, everything that we've covered in the module. Obviously, there's the basics, which we've done in term 1. You can think of term 1 as the basics of that understanding. Object-oriented design is something you already were taught. We just updated your knowledge to a different programming language. New concepts we introduced, things like working with a graphical user interface, things like working with Java-only features, such as Lambda functions, such as interfaces. If you look at the next term, there you're going to learn something that's also going to be very important, something called design patterns. Those are best practice type of things. There's a certain amount of them we're going to have a look at. There's obviously a lot more, but we're not going to be able to do all of them right now. So you'll see we'll do some of that. We'll also do multi-threaded programming. All of these different concepts are going to be sort of tested in your practical X. This might move a little bit later, depending on the semester test 3 situation. Okay, so what we're going to have a look at now is we're going to look at the design or the structure of practical X. So the practical X is 2 components. First component is looking at just the design. So this is what you're going to spend your time on in recess or even after recess in thinking about what you want to actually do. So obviously this is last year's one. This will be updated obviously for this year. So you'll see practical X and you'll also see the design. So first you have to design what you actually want to do. Now there's a couple of components that you're going to have a look at in terms of your design. You as a student will be given a unique set of choices. So every one of you will have a unique set of choices. You will choose out of those choices your appropriate things. What those could be is you're going to have to choose a category for the game. You're going to have to choose a subcategory. You're going to have to choose a genre, and then you're going to have to choose design patterns to pair along with what you get. So your combination will obviously be unique to you, your choices, and then you have to pick one for each of those categories. So that's first part of your design. What are you going to build? Now, that already obviously depends on what you think you're capable of. If you understand how a certain game works, you do that one. If you find something a bit easier to implement, you understand that better, that's the one you should aim for. We are not testing if you can build the next best, greatest game. What we are trying to test is your design principles. We want to test that you understand how to design a system, or at least part of it. One important thing, you are not allowed to use any third-party library. So no jar files outside of the JDK and JavaFX, nothing else. You have to write everything on your own. There are going to be one set of things which we will provide you, and that is some things to make your game development journey a little bit easier. So there will be a set of provided classes in a jar file, but that's us providing it to you. So JDK, JavaFX, and that one jar file we provide to you. So what is your design going to be? It's going to be a description of the game you're designing, whatever you're going to do for Practical X. You're going to choose a category, you're going to choose a subcategory, you're going to choose the genre, you're going to choose a design pattern. Now, it's important to note that whichever design pattern you choose, we're going to see whether or not you implement that correctly in your game design. It has to be one of the ones that are given to you. So if you are only given the choice of an abstract factory and object pool, you have to choose one of those two. Obviously, you can't choose observer if it's not in your pool of choices. So that's just the first part. The second part of your design is what are the rules and conditions for your game? How do you play the game? What happens at each of the circumstances? Now, this, again, it's not going to be very complex, but you need to indicate what you need to do in the game. So that's your objective. You need to indicate the rules of the game. How is the game actually played? How do you win? And how do you lose? That's the 4 parts that we need for rules and conditions. Now, there are some restrictions on how you actually play the game. And you will see there's a list of games that are sort of banned. And there's a reason for that. No card games, so no poker, no blackjack, no Uno, nothing like that. Because those are known rules, known conditions, known implementations. No textual games, so nothing about like a quiz or Sudoku or Hangman, crosswords, nothing like that. No memory or matching pairs, no checkers, no tic-tac-toe, none of these games that there is a lot of tutorials or videos or descriptions or just plain code on the internet for. We don't want you to just copy code off the internet and say, okay, here's my game. We want you to design it on your own. Thing I want to point out here, nothing should be random chance. It shouldn't be a user clicks a button and if it gets above 10, they win. If it gets below 10, they lose. That's not a game. That's clicking a button. It has to be something the user actually does. Now you can decide what you want to do. Do you want the user to move someone around the screen? Do you want them to click with the mouse or move with the mouse? Or do you want to use a combination? That all depends on what you actually choose in your different categories and subcategories and genres. Then the last part, you're looking at the UML class diagram. So this is looking at the UML class diagram as a whole. You need to design the system. In part of designing the system, you need to identify what UML is going to, or the class diagram is going to look like. What classes are they going to be? Are there classes for the player? Are there classes for enemies or different enemy types? Are there classes for handling object pool, factory, whatever design pattern you're going to choose? There's also going to be classes for your GUI interfaces. You're going to have your application class, which houses all your other components. That's going to be the scene that you set on your stage. If you want to have multiple scenes, you can do that as well. But obviously, you have to design these different classes and how they interact. So that will contain all of your different things. And one thing you'll notice here is you have a design pattern that you will choose, but you will also be using the visitor design pattern. So that has to play a role. What is the visitor design pattern? When you go through design patterns, you'll find out what exactly the visitor design pattern is. So this is just the design of the actual game, not the final version. It's not the version that you need to do. What you actually have to do is then build that game, build that system. It has to be a JavaFX graphical user interface, because that's how the user is going to actually play or interact with your game. And you have to use both text and binary in some sort of way. Text files and binary files. Text files must be used to create model classes. So you've seen that already. We had your practicals do that. You've seen the tutorials do that, where you have text files that describe model classes. And then binary data, we had a look at that for some of the things, but you can use this for loading and saving game state. So if someone is playing your game, they decide, okay, I need to take a break, they can save your game, come back later, and load it up again. So that's the two ways you're going to be using files. It has to do this. There's no other way of specifying that. You have to do that. You decide how you want to store those files. You decide what goes into those text files, what goes into those binary files. You decide all of that. You are designing the system. Now, obviously, you had a UML that has all the other classes, so you have to put those things into practice now. Some other things, this is more for us to check things. You have to include some screenshots, screen captures of your game. Just a picture showing the game at the start, winning and losing. That's just pictures of the actual running game. Okay. So one other thing which I think I skipped over. Yep. So there's another section there. Maybe I'll make this a bit more bold in the next version of this document. You have to tell the user how to play your game. It's one of the things that's going to be important. The user won't know how to actually do anything unless you tell them. So either through another screen, little help window, something, you need to indicate to the user how to actually play your game. So all of that all together, there's also a bonus. So you can do images instead of just using boxes or circles. You can actually put images as well. You have to make sure that the images are not copyrighted. It has to be referenced correctly. And then if they're not copyrighted, not referenced correctly, then you can actually get your bonus marks. So what's interesting here, which I'm actually going to go to a different document, there is a mark sheet here, but we'll look at the mark sheet like this. So here we actually check that you do those certain things. The reason why I need to talk about the mark sheet is this is how we're going to check what you do. You have this information available, you know how it's going to be marked, make sure you do those certain things. We said that you have to use text files for doing something. We check that you do text files. You have to do binary files for something. We check that you do binary files. So obviously, if you don't do one of these things, you're going to lose 10 marks. And that is 10%, because that's what the final thing is out of. Then for the GUI interface, you can see there's marks for the instruction manual, marks for game info, marks for game objects, and actually using interaction either via mouse or keyboard. We've seen some of that keyboard interaction, moving the mouse around with checking for mouse events. I spoke to you about using keyboard events, mouse click events. I didn't show you all of that, but I did tell you it's there. It's your job to go in, find out more information. Where do you go find out more information? Not Stack Overflow, not another random programming website, JavaDoc. That gives you the information you need. Don't rely on the internet to do your work for you. You need to do it. Then we have visitor design pattern. Do you have everything necessary for that? And whatever you choose as your other design pattern. If you actually look at the marks for the game, it's only 10 marks. So if your game isn't very good, it's not going to be a train smash in terms of the rest of the marks. What are we actually checking? Can you write code that actually does work? Can you write code that does text file and binary file input and output? Are you using design patterns correctly? This is what we are testing. Other things we check, so make sure you include the screenshots. Packages, are you actually using packages? Do you have a coding convention that you actually follow? These are the things you do every practical anyway, but we still need to check that in this practical X. Inline commenting, Java commenting, execution, obviously that should run. There's no choice about that. Then, does it actually compile? This is more for if it doesn't compile, then obviously we don't award marks for that. That's for every practical. And does it actually match the design you described? So if you say you're going to have the next Formula One game and you decide to instead make Pac-Man, obviously that doesn't match. That's a problem. So we check that, and then for bonus, we look at whatever extra things, whatever you do beyond the scope of what we told you. Now, there has been over the years some very interesting games being created. I'm not going to show them to you because I did that one year and everybody tried to copy that one project. So rather you try on your own to do whatever you need to do. So that is essentially what Practical X is all about. Designing something and then actually delivering on that design. So these dates are still going to be 2021, but you can use the learning guide as it is on Eve right now for the dates for this year, 2022. You can start working on it right now if you want to. Now, speaking about recess, some of you will have a recess. Some of you will have a break. You can enjoy not doing academic work. However, you looking at the class as a whole, there are a number of you who are at risk. And I spoke about at risk in one of the previous lectures or tutorials. If you are at risk, which means that on Eve, it says at risk next to your name under the mark fields, that means you are required to attend an intensive revision session during recess. The details of that intensive revision will be made available on Eve. It will probably be happening next week, Wednesday. But the exact details will be made available on Eve. It will be virtual. It will not be on campus. It will be virtual. You have to attend virtually, most likely on Blackboard. So if you are at risk, you are required to attend. Not watch the video afterwards. You are required to attend the live session. If you do not attend when you are at risk, there will be consequences. If you are not at risk, but you still want to attend, not a problem. You can go and view intensive revision. Same person who is providing intensive revision is the same person that you see at the Saturday classes. So it's the same person giving you that information. Okay, so other things we need to talk about is semester test 1 or summative assessment opportunity 1. The papers have been moderated. I still need to update the marks on Eve, but the papers have been moderated. And because of timing situations, you probably won't get access to your physical copies until next term. So next term, you can collect your actual paper, and then during next term, Mr. Situngu will go through essentially the memo for the test. So you can check that where you went right, where you went wrong, and if there's a discrepancy with marking, you can come and query that mark and have it corrected. So that will most likely happen next term, because obviously you won't be able to do that by tomorrow. Those of you who wrote the SSA, I finished marking that. It still has to get moderated. And all SSA paper gets moderated, so there won't be any marks put on Eve until the moderation is done. So most likely that will happen, it will be completed probably in the middle of recess or at the after recess, and you'll get your marks for that in term 2. So that's the situation currently with your semester test 1. As far as semester test 2 or SAO2, that is your practical test. You will see that in week 8, the week you come back, we do give you a past paper as practice. So that will be just as you had this past week. You will get given the paper at the start of the session. You need to be done by the end of the session. And just to give you an idea of the scope, what you did on Tuesday was 1/3 of the paper that you need to do in the practice test. So if you struggled with that, I would suggest you spend your recess actually brushing up on writing code. You'll also note that we do revision until the test actually happens. That Monday will also be revision because I'll move this design patterns to lecture 12 onwards. So lecture 11 will actually be down here, and that will cover up until the Monday. There are other timetable changes and that during the semester. There's also some holidays in between, but we'll handle that as we get there. And as you should know, semester test 3 will be written on a Monday instead of a Tuesday, because again, COVID policy, no venues, so we had to move the test. But that details are already inside Learning Guide. That shows when we start and when we end. There is this which mentions cutoff dates for SSA applications. Make sure you pay attention to those. Those are cut-off dates, not when the test is written. That's the last day you can apply to write the SSA. If you apply after this point, then your application might be rejected. All depends on what documentation you provide. Okay, so I think that's all that I need to talk about for Practical X. If you do have questions about Practical X, you can always email. But we're going to jump back now to looking at some code. Okay, so before I do that, I don't see any questions in the physical venue. I'll just check on Blackboard if there's anything. So, okay, so you're only allowed to choose things that are offered in your pool. So if your thing has choice A, B, C, you're only allowed to choose A or B or C. People who aren't at risk can attend. I did mention that already. And will Prac X be part of the PCM mark? I shouldn't have closed the learning guide. So let me just get the learning guide again. I get asked a lot, how do you calculate PCM? There's your answer there. To calculate your PCM, you take your practical assignments, you take Prac X, and you take your second semester test. In those ratios, add them up, that's your practical component mark. That has to be above 50% or above for exam entrance. There you can see there, minimum 50%. If you look at this, what are two big factors? Your practical semester test and Prac X. Prac X counts as much as your weekly practicals. So that's something very important to have a look at. Okay, so some other questions. Can we use third-party assets that aren't libraries? So the only assets you're allowed to use is images, and for those images you have to have it referenced. Okay, bounded generic classes, we'll have a look at that now. And then another question I get asked, how many practicals do you count? 80% of given practicals. So if I give out 10 practicals, I count the top 8. If I give out more, it will be 80% of that number. Okay, so, right, no other questions. So one question that I did see there, which we need to talk about, is bounded classes. So let's go have a look at the lecture, and then we'll have a look at code for it as well. So in terms of generics, we spoke about having unbounded types and bounded types. Unbounded types means that for a type parameter, so if we're looking at a type parameter like this t here, this type parameter is unbounded, which means that there's no restriction on it. That type parameter can be anything. It can be object, it can be student, it can be exoplanet, it can be string, it can be integer, it can be double, it can be anything. So that's unbounded types. If we look at bounded types, there's a restriction. What restriction? Depends on what type of bound we're putting on. It can be a normal bound or a lower bound. We can see that examples here on the slide. Bounded means that it has to extend a type. We're putting a restriction on the type that is allowed. So that type parameter, if we say, for example here, we say t extends something, it has to extend that class. Either directly or indirectly, it has to be part of that class hierarchy. If we look at the other one, lower bounded, then we talk about super. So it has to be one of the classes or one of the super classes of that type. So we're just restricting what can actually fit as a type parameter. And the last sort of type we can put is a raw type. And raw type basically says we instantiate something that is a generic class or method without specifying a type parameter, and by default that goes to object. So raw type means we provide object as a type parameter by default. So we can see an example of this. So if you go back to our code, here we have a test class we created, a generic class that we wanted to work with. And at the moment, there's no restriction on our type parameter. So in our main, we can create any sort of type for this, and there's no problem. We can fit anything into that type parameter. However, if we change it up, and we go into the class itself, and we say something like extends number. So what is number? So if you go look at number, number is a superclass of the classes that are wrapper types for byte, double, float, int, long, and short. So that's what number is. Now, if you go look at main, the one which takes an integer as parameter still works perfectly fine. There's no restriction here that does not match. Integer is something that extends number. Integer is something that extends number. So this works perfectly fine. However, string doesn't extend number. So it does not match our restriction. Our restriction says whatever type we provide has to extend number. So therefore, the compiler is complaining that string is not a valid substitute for the bounded parameter. It cannot put string there because it does not extend number. So that's how we can put bounded type parameters for our generic classes. We can stop whoever's using our code from putting incorrect things inside of there. What's nice about doing things this way is that in our class, we can now work with this type parameter as if it's a number reference. So say, for example, here, we can do something like this dot, and if we zoom in, okay, this dot state, that's what we want to have a look at. And we can see here, we can get methods that are available in the number class. Because we put a restriction on t, t has to be something that extends number. So the lowest common denominator in this case is that it's a number, and we can call any methods that number has. So here you can see there's byte value, double value, float value, int value, long value, short value, and that seems like that's all the things that we can get out of number. So if we go look at the number class again, and we go look at the outline, we can see these all abstract methods, and they will be implemented in their respective subclasses. So if we go look at integer, for example, and we go look at something like so there's double value. It has to implement this method, so you can see it just takes the value and converts it to double. There's a float value, converts it to a float, so whatever the case may be. So that's how you can use bounded types to restrict type parameters to something specific. In our situation, maybe with working with the education system that we are developing, it might make sense that we restrict our things to, if we're looking at student and lecturer, both students and lecturer have person as an abstract base class. We might have all our lists be array lists that extends person, so that we can put anything inside of it. Maybe you want to restrict it only to students, then you just put that type as student. We have some very lively people outside. Hopefully you can still hear me fine. Okay, so let's look at something that we were doing in these education classes that we need to kind of change. At this point in time, we were still using manual arrays, dynamic arrays that we create and manage on our own. We have to keep track of the array, its size, and index. All of those things can be managed by an array list. So let's see how would we change this code now to work with an array list. So obviously we want to change this to an array list. And what type we're going to have for this one here, it's going to be student, because that's what it should be. And let's just say we just want to convert it directly there to student. Now, if we do this, obviously our code won't compile because everything still relies on those variables being those types. So we have to go fix up our code. So inside of here, you can see obviously the constructor doesn't make sense because we're not initializing a new manual array. We're working with an array list, so this should change. So we can have an array list here. If you look at the constructors that are available, we have one that takes in no arguments, but we can provide either one that takes in a collection, so another array list or something else, or we can specify an initial capacity. We kind of did that with our array list, with our array here, we said something like 10. That could be the default that we provide. Other places where we use this is, I think there's only this method that's left. Here we were keeping track of a number of things. If we try and register a student, we first check if the student is null. If the student is not null, then we can check if the student number matches something that's already in our array. We don't want to register a student that's already registered. That's what we're doing here. So we had to do this manually because we're working with an array. Same thing goes if we go out of our size. If our length of our array is too small, we have to resize our array and then put all the elements back in. So we could, yeah, you can see we create a copy that's twice the length. And then finally, we could then put that new student at the correct index, which we had to keep track of manually as well. So obviously, we can't do any of this anymore because we're now using an array list. But array list gives us some functionality that will assist us. We are returning a Boolean if we're successful, or false, true if we're successful, or false if we're not successful. So where do we return false? The only time we return false is when we're trying to add a student that already is in the system. So how can we check that? So if we look at the array list, and we should really use proper coding convention. So we should have this dot students. You can see there's a method called contains. That method returns a Boolean whether or not this array list contains that reference. So this returns exactly what I want. I want to check if the student is already added. So if the student is already added, then we can say return false. Now, just to make sure things are nice, we're going to put that into brackets just to make sure that we don't have any issues with understanding what is going on. So that takes care of that part of the code. Next part of the code, we had to resize the array if it was too small. Now, ArrayList does this automatically. We don't have to worry about that. So we can just write code to add a student, and that replaces all of that code. A lot less work to do what we are doing manually. What's nice about using code that has been tested for a long time, usually, I have to say usually because not 100%, usually there's no errors, no bugs that are in those types of systems. So we can be fairly certain that this will be a lot better than code we write ourselves. Because the code we wrote ourselves, we did not test it. We wrote code that might work, but there might be a situation where it doesn't. So another place we use students was down here as an accessor method. Now, with accessor methods than access arrays, there's different ways we can handle this. We could return our reference directly. We could say, here is our array list directly. But what can happen is, whoever calls this accessor method now has a reference to our internal state, and they can add things if they want to, without going through the register method. So another way we can do this is, firstly, change this to be an array list, because it has to match the type. But instead of returning that, we can return a new array list that makes a copy of our current array list. So that way, that person will get a copy, and they can modify the copy whatever they want. Our internal state still stays exactly the same. So another problem with trying to work with a manual array instead of an array list is, with a manual array, when we resize, how many elements are there? Depends what number we resize to. So if we started with 10 and resize to 20, we have 10 things that are full and 10 things that are null. So there's nulls in our array. Anytime we iterate over that array, we have to check, is this thing null? With an array list, when we're getting information out of the array list, it will skip over nulls. So we won't get null references back. So that's something that we can change as well in our code. So here you can see example for modules. So oops, wrong place. So with module over here, we creating it manually. Again, there should be a section here where you do the resize and check if it already contains something manually. We can change this just the same way we changed the student. The one thing we can then get rid of is null checks. We don't need to check for nulls because the array should be full at all times. If we remove something out of that array, now we can write that code very easily, because with add methods, usually you get remove methods, and you can remove stuff as well. So we can write, for example, this was a register student. We can write now a deregister student. We have an add module. We can have now a remove module. And that can work now because we don't have to write so much code to actually implement that. If we were still working with manual arrays like this, we have to keep track of which index we want to remove, copy the first part of the array, don't copy that element, copy the last part of the array, put it together, take it out. Oh, it might be a null reference. Make sure we move all the nulls to the end. Lots of things to take into account when we need to change the size of something by removing a specific element. Question? So is an array list an automatic array in the sense that it will dynamically resize itself when needed? It does that internally. So we were doing it manually before. We can see the manual code here where we create a copy of. If you go look at the implementation of array list somewhere here, you'll see there's a method there. And that method there, you can see there, it does actually the copy that makes it bigger. So it does that, but you saw there was a couple of extra things it checks. It checks things like old capacity, new capacity. Here it's basically multiplying by 2. So if you know your left shift and right shift, if you're shifting right, you're multiplying by 2. If you're shifting left, you're dividing by 2. So that's times 2, but shifts are usually less CPU cycles than multiplies. So optimize code in conjunction with additional checks. So it does do a bigger array, dynamic array, but it can also shrink the size. So it's not just make it bigger, it can also shrink the size to not take up as much memory if need be. So there's a whole bunch of extra things that it makes sure to do. So here's the example of trimming the array list to the correct size. So that will make sure the internal array gets resized correctly. And if you look at the actual array that we have, the element data, it's an object array. So it uses a type parameter, but remember we cannot create an array of a generic type. We have to typecast it from an object array. So they just work with object arrays internally. So a lot of these things we had to think about ourselves. It does it automatically because someone else has written this code, probably more than one person, over the lifetime of ArrayList, and they've optimized it to make sure it works really well. So it's more than just saying it's a dynamic array. It's a dynamic array plus additional features. There was another question somewhere? No? Okay. Let me just check online. Well, I can't do much about the background sounds. So Pre-allocation, yes, that's the same, but obviously resizing it and making it smaller. We didn't do this make smaller part. All right, so we are at the end of the session, so I'm going to stop the recording there. We still have another tutorial tomorrow, so I'll see you all tomorrow. If you do have any questions, I'll be at the front.